Thank you. Can everyone hear me okay? If I speak too quickly, stop me. This happens a lot. My name is Dave Wilson. I work for HEAnet, which is the Irish National Research Network. And I work in the Network Development Department. Most of my day job is managing and developing the network that we're deploying there on a number of different levels. I'm the layer 3 guy. One of the interesting things we're doing, though, we're looking at is we're developing some software. Not just us, a consortium of a number of organizations. But what we have in mind is software to permit virtualization of our layer 3 network over the coming years. And we call it Manticore. We're just at the end of the second phase of that project. We're about to release some code. And I'll talk a bit about what it's about, what the code does, and the framework surrounding it and what we plan to use it for, including how we're asking for some more money. Now, the project itself, wall of text. What the project really is, what it really does, is on a very simple level, and don't be misled by this, it's a provisioning system for virtual networks. That's a more powerful idea than it appears at first. It's just a provisioning system here. Provisioning systems are ready. But what we're looking at in particular is the capabilities of a lot of routers, GNOS routers in particular, but Cisco routers as well, depending on the type you get, to provide virtual routers, logical routers. More than just a layer 3 VPN or a VRF. What we're looking at here is something that's, I know today not quite as separate as almost a VMware instance of a router, but certainly the idea that you have a router into which a customer can log in, have a reasonable level of autonomy and independence, and configure their own network. Which leads to the idea where we're already able to provision layer 2 links between devices. If you can provision layer 3 routers, then you can create entire logical networks. You can draw a picture of a network, turn a crank, and suddenly it's real. And we think that's quite a powerful idea. So what we have in mind in this project is we want to build a system which we will deploy on operational networks and hand over large chunks of the autonomy to users. That the user, say, we give to the user, here are your interfaces, here's the boundary of your network, the resources we're providing. Build the network as you wish inside those boundaries. Come back to us if you need more. We've been doing this now, we've been working on this for a couple of years, and we have plans to go further. We built a prototype, and we're at the level now where we're finishing the implementation of the tool itself. Something that will still be deployed in our lab. We won't be deploying on our real network for a little while yet. But with the participating partners, universities included, and also a number of entrants and Telefonica and ITCAT are doing the doing the actual coding. We're getting this tool together. The object of the exercise, it's about the services. In particular, what we've done in our national research network and many other national research networks across Europe have done in the past few years is go from offering simple layer 3 connectivity to offering a number of different services, usually going down in layers. In particular, offering bandwidth on demand. We users, you'll very often find physicists as the perfect example here, but a number of different types of users who require a particular dedicated channel or just plenty of bandwidth to a particular place or a number of places. We go, okay, we'll sort you out with a VLAN, and you can run a gig across this VLAN and it'll be unattended. Or, oh, you need 10 gig, have a wavelength. Oh, you need a few of them, have a few wavelengths. And we put the infrastructure in place to support this. But our users have their own expertise and have their own areas of specialization. And it's not the same as mine. I'm the layer 3 guy. It's very easy for me to go to a customer. Oh, okay, you want 10 gig of bandwidth. Here's a 10 gig wavelength. Off we go and connect it. Oh, you want IP addresses? Oh, sure, I can sort you out with IP addresses. Oh, you want addresses that work at both ends? Oh, and the other end is in a different country. Oh, well, then you need to run BGP, and they need to. Oh, they don't have that relationship with the computer service department. Oh, I see. Then you need to buy lots of routers. And that's where it gets bogged down. I think that kind of service, you just have some bandwidth thing, isn't enough. It certainly is for a lot of our users. And it's worked very well for where we deployed it. We deployed our layer 2 network on dark fiber over the past few years, and it's had far more use independent of our IP network than we expected. We've been delighted with it. It's mostly been internal to an institution though. Not exclusively, mostly. There are a lot of challenges in between. Now, I'm not going to be able to solve those challenges overnight, but I think this is an essential tool in doing that. The object here, you have a substrate of physical devices. These are my physical routers now on my network. We have bandwidth between them. We have a network which is provided to a single user with a particular purpose, with some connectivity between them. That's an internal network, not really to anyone else. Using the same hardware, I have another network provided to different users with their own requirements, with their own routing requirements in particular, with their own bandwidth requirements, and with their own connectivity. We'll have a third network to another user who wants to how dare they, connect to the internet and have a routing policy which prevents that. And this isn't necessarily in a single country. It can be across quite an infrastructure, although it is in principle single domain. But what we've gone and done there, by making these three logical networks on a single network, these logical networks, all of which have their own autonomy, all of which have the user's own ability to define the routing protocols and define what they're running on the network, is we've taken a really abstract description of a network and made it real, with a minimum of messing around on the user's part and a minimum of messing around on my part. The entire description, formal description that you need to make one of those networks is you have to define the edge ports. You might have to define an external routing service if you have one. And for most of our customers, I reckon that would be, there is the default route, and here are the routes which you announce. You'll probably have to define some sort of internal transport, but this doesn't mean getting down to you need to configure OSPF on this interface and on that interface and give it a cost. This can be as simple as I want to connect together and just take the shortest path. Go and define OSPF stuff for me. That can be automatic, or it could be more complex, but you can still abstract it to something like I want it based on the millisecond distance, or I want it based on the bandwidth available, or I want it based on some other calculation, and then you pump that into an algorithm and then pop your OSPF for your ISS costs. You'll probably have to provide some IP addresses, or RC1918, or public, whatever you like. But again, you shouldn't have to go around every single interface partitioning them up and going, here's a /30, here's a /30. We have computers to do this for us. That's quite an abstract definition of a network, and it is entirely sufficient to build a network out of, I won't say out of thin air, but to build a perfectly good, best current practice configuration of a network. The reason I'm so concerned now is the easy bit for configuring networks until now has been, once the router is in place, once the physical infrastructure is in place, we just configure something up by hand, or perhaps we have a provisioning system for this particular network. But now, where it's possible to draw a picture and configure up the infrastructure, the underlying infrastructure itself, it's most important, I think, to make sure we abstract out configuration as well. The framework this is built on is the infrastructure as a service framework. This comes out of Canada, the Canary guys. There is a framework there, a code you can get, which is about modularizing the network and modularizing the provisioning of the network. I won't go very deep into it myself, it's a huge area. The way the Manticore software architecture itself works is with web services. And again, I won't go deep into the nasties here, but the interesting thing about what you see here is the user has drawn a picture of a network in a GUI, and it's translated through an IP network web service, ultimately into particular configurations for a particular device. The policies management, the user accounts themselves are managed independently. And this comes down to actual configuration that the user can do, like configuring your external gateway protocol, your internal gateway protocol. But we probably need a static route to lodge this. Drop it in, please. Thank you very much. For the user. We have, one of the reasons we've been so anxious to get multiple partners in this one is to make sure that it covers well a bunch of different use cases. And in fact, these slides aren't mine. You'll have slides from a number of different parts coming up in the next short while. But the biggies are, we have to provide, as I see it, IP network services and not just bandwidth to users. And not just, here's your IP address and we'll route it for you, don't worry your pretty little head, but how would you like it routed? I know you're not a routing person, but what kind of network do you need to build here? And also handling the problems with what I see as routing integrity, which I'll come to in a moment. And also there's some interesting applications on the matters of energy availability and green computing areas. Now, again, I won't go out of the wall of text, but this is going back to the notion that we have providers, commercial and otherwise, providing network services with basically many different physical networks, providing many different physical services. And the limitation here isn't bandwidth, it's something other than bandwidth. It's basically a software limitation. I have to have 2 or 3 or 4 or 5 different routing policies and independent implementation of these things. So what we do, I was afraid this would happen. I fortunately have something to talk about, but this was very, very slowly indeed. What we end up doing is, at the moment, every time you need to provide a new network that's subtly different from the previous one, even if you have the bandwidth already there, even if you have the backbone capability, the backplane capability inside your existing routers. Even if there is no problem sending those packets into an interface that you have on your existing kit, and then an interface you have on your existing kit, and getting it routed in between, we still end up buying different routers because we have to configure different routing on it, which is absurd. And that's another problem that's already fixed and has already been fixed for some time. That's where the concept of logical routers comes from. You can do this easily in GNOS. You can do it with SDR in a TREX with physical devices. And there's some interesting stuff in the Nexus routers or Nexus switches as well. And of course, you can always have VMware and Zorp or something like that on a custom box. Loyalty Core can handle each of these scenarios, or is modular enough to be able to handle any scenario that you throw as principal. And the concept here is you only need the routers to handle the physical bandwidth, the physical backplane capacity, the physical services that you're running. And the fact that you're running 3 or 4 or 5 or a dozen different internets shouldn't matter.